Hey, here's some problems worked out that on your practice worksheet before you take your graded assignment. So the directions are simplify, complete on paper, and show your work. So I'm going to complete right here looking at number 1. Going to look at my indexes. They are all the same. So I'm trying to get lighter highlighter, but I can't find it right now. So I'm going to look at my indexes. They're all the same, square root of 2. So then I look at my radicands. Can I combine any of these? Well, looking at my radicands right now, initially I would say no. But more than likely, I have to break these down. So I'm going to ignore the 3 right now. Come back to that when I'm done. And I'm thinking perfect squares again because my index is 2. So some perfect squares. 2 times 2 is 4, 3 times 3 is 9, 16, 25, 6 times 6 is 36, so on and so forth. Keep going. So I'm looking for the largest perfect square that goes into 18. 16 is too big, so what about 9? Yes, 9 times radical 2 works. What is the square root of 9? 3, and I'm left with radical 2. So now I have an outside number here and an outside number here, and you multiply those together. So 3 radical 18 breaks down to 9 radical 2. I'm going to bring my plus sign straight down. Looking at 2 radical 8, I know that radical 8 has a perfect square of 4 that will go into it. And I also know that the square root of 4 is 2. So 8 radical 8 breaks down to 2 radical 2. So now I've got a 2 outside and a 2 outside here. What do you do with those numbers? Hopefully you said multiply. So 4 radical 2. Then I bring down my minus sign. So I have a 2 here. I'm going to ignore it a minute. See if I can find a perfect square that goes into 27. 16 is too big. 9 square root of 9 times 3. So the square root of 9 times the square root of 3 is 27. What is the square root of 9? 3. And I'm left with a radical 3 inside. So I have a number outside here, outside here. What do you do with those numbers? You multiply. So 2 times 3 is 6, radical 3. So now that I've got that, I'm going to look and see if any other radicands are the same. Got a radical 2 here and a radical 2 here. So I know that I can combine those two things. So 9 plus 4 is 13, radical 2. I cannot combine the radical 3 because the radicand is not the same as radical 2. So I just bring it down, 6 radical 3. So there's your answer for number 1. Let me see if I can find a more difficult one to do, or just pick one, I guess. Let me do 6 with you or for you. So if I'm doing number 6, I'm going to ignore my negative because I know it's a negative 1 right now. I'm just going to ignore that. And I'm looking at my radicands. They are not the same. The 2 3s are, but the 12 is not. And I look at my indexes. They are all square roots. So I'm good to combine if I can. I'm going to wait and combine those at the end. I'm going to see if I can do anything with that 12 first. And if I'm thinking about it, I know a perfect square that goes into 12. You get 4 times 3. What is the square root of 4? 2, radical 3. So is there a number outside? Well, technically there's a negative 1 there. So negative 1 times 2 is negative 2 radical 3. And then I have plus 2 radical 3 plus 2 radical 3. So combining all of those things, I simply just start to combine them. I look at my negative 2 radical 3's and I add a positive 2. That cancels out and I'm left with 0. So my final answer is 2 radical 3. So I'll do one of these. I will not test you on the cubed roots, but just so you know how to do it. And if you don't want to go on to the cubes, you can stop the video here. So if I'm looking at the cubed root, I'm looking, my indexes are the same. These radicands are the same, but that 32, it's going to probably break down. So, oops, not the 3, sorry. I was thinking in my head. So it's going to break down. It's going to break down to cubed root of something times a cubed root of something. So remember my cubed roots, 2 cubed is 8, 3 cubed is 27. Well, I don't need to go any further because 27 is too big, so let me see if 8 will go into 32. And if I know my math facts, 8 times 4 is 32. So now, what is the cubed root of 8? Well, that's 2. And I'm left with the cubed root of 4. So that's what the cubed root of 32 breaks down to the cubed root of 4. And there's a plus here. So now I have a radicands are all the same. My indexes are all the same, so I'm going to go ahead and add that. I have 1 plus 1, so I have 2, the cubed root of 4, plus 2, the cubed root of 4, giving me 4, the cubed root of 4. And just so you know, some of you may be thinking, well, why can't I take that 4 out? You can't because it's not the square root. It's not 2 squared, which is 4. Your index is 3, so you have to use the 3. You have to use for a cubed root of 8. The 4 does not fit because of that 3 index. So there's your final answer. I hope